Hello everyone and welcome to yet another Python video. Here we're going to cover the stack class, so prepare. This video might be a little bit longer than the others. So why don't you grab a bag of popcorn or your favorite snack and we will get started. So creating a stack class is a little bit easier than in other languages like C++ or Java. For the most part, what we will be doing is that we will be using the list as kind of the backbone for the stack, and in this stack we'll be using a list. And the only difference between a list and our stack class in here is that we'll just be accessing the list in a very specific way. So let's start off with the constructor. So with the constructor here, what I'm going to do, well, I need to define the class first. Class stack is not going to inherit from another class. So we have our class stack, and we will start with the constructor. Self, and so this I consider two important pieces of data when it comes to the stack. And we'll define an empty data, and I'll put an underscore off of it so I know it's an interior variable, an attribute for the class. So I'll create a data variable called data, and it's just an empty list. And I would consider another variable called size, but data itself already has a size when we calculate len, so I'll take a look at kind of manipulating and simulating that we have an attribute called size. So here's what I just want to do with it, and actually if I'd like to add some customability to this constructor with adding a optional parameter, so we could have a parameterized default constructor. So I'm going to say init value, and this is in case someone wants to initialize a stack with 1 value or with 0 values. And since we're going to give the option, I'm going to give a default argument, which will be none. Right, so first we'll create our list, and then we're going to check if our init value is not equal to none. If it is not equal to none, what we'll do is self dot data, and we'll append the init value. Actually, what I'll do, I'll say self push init value. I'll call my push function so that we were forced to define it. This error should say that, well, we'll call this function later. So if init value is not equal to none, we're going to push it to our stack. So next comes the destructor, and actually the destructor, there isn't a lot of things to do. So what I'll do for the destructor here is I'll use the pass keyword to say that we're going to do nothing, because Python will destroy the list by itself on its own without me having to do anything. What comes next is that I'd like to print and see, I'd like to work on the string method, the string special method, to kind of show how I'd like to print the class. I want to detail how I'd like to print the class. So one thing about casting it as a string is that the values in the stack are generalized. They can be numerical data, they can be other classes, they can be strings, right? But as we'll test when we create our stack fully, and in the next video a queue, when we want to test our stack in queue, we want to add different things, and who knows, we might have a stack of multiple data types, a mixture of data types that could contain, let's say, I don't know, other lists, dictionaries, numbers, strings, other classes, that kind of thing. I want to keep it a little bit generalized. So what I'll do is I'll create a list comprehension called string temp. So I will say for casting to a string of I, for I in self dot data. Right, so what string temp is just the same data that's in our stack, just casted as a string, which seems pretty nice. And what I'd like to do is kind of similar to our class with our triangle class in the previous video, is to make our values space separated. So what I'll do is I'll say my class, or I'll say stack string is equal to this, a set of a string that's just a space, and I'm going to join my string temp. So it's going to take all the elements in this string temp and it's going to join them together and make them space separated values. Right, once that's done, well, we achieved what we'd like to do. So here to review what we've done is that we used a list comprehension to convert the data in self data to a string, each element inside that list, and we store it into a variable called string temp. And stack string is going to be a space, and we use the dot join method for the string. And we take every element inside of the stack, and for each element after we insert a space, so everything is going to be space separated. Once that is done, we want to return our stack string, which isn't too bad. Right, so let's review real quick. We have our constructor, we have our destructor, here we have our convert to string. This is also the same as overloading the double angle bracket operator in C++. Right, so now let's look at overloading the equals operator. So say same as, well, we'll just say overloading the double equals operator. We'll say def eq self and other. Right, and remember, this is what it'll look like in practice. Okay, so the first thing to check is the size. So is self dot size is not equal to other dot size. We are going to return false. Otherwise, what we're going to do is that we're going to abuse the overloaded operator for the list class and just say if self.data is equal to other.data, we're going to return true. Otherwise, we're going to return false. And that should be it. So because we did the double equals operator, it only makes sense to do the not equals operator. So we'll move on to that. Okay, and well, we need to do something like, we need to do another check that's going to be similar. Now here, instead of returning false, we actually want to return true, because we want to check if they're equal or not, and if they're not the same size, well, they're not equal. Right, so I'll take something similar to this, get rid of these extra lines, and so now we'll check. So otherwise, if self data does not equal other data, we'll return true. That is correct, because this is a situation where they are not equal. Otherwise, we will return false. So this is a little bit easier to implement, because we had a basis, which is the equals operator that we had above here. So overloading the not equals operator. Let's make that a little bit clean, and then we'll use the example. Self does not equal other. So this is what will be done when it comes to overloading operators, and this will be the end of our special methods for this class. Now, one could overload the plus operator, meaning the add operator, the special method, so that way we could concatenate two stacks, but this will not be covered in this video. So next what we will define is a getter called size. It will take itself as a parameter. Let's put it one more down. What it'll do is it'll return the length of self data. So this gives, the illusion of some sort of attribute that's part of it called size. Right, but really we're using the list that's contained inside of the class, which is right here, and we're just returning that length. Pretty simple. So with stacks, one of the most important things that belong to the data structure is the top. And with that, we'll define a getter function called top. And since top just returns one element, we want to return the last element in the list. So we'll return self data with the underscore. And one thing that you could do is you can say length of self.data -1. Right, and this makes sense. We'll take the total number of elements and we'll subtract 1 because lists start with a 0 index, and this will do the job. But that's not a very Python way of doing that. We'll use the -1 index, which means the last element of the list. Pretty simple, huh? Next, what we'll cover is one of the most important functions, which is the push function, how we add data to the stack. And we'll call it push self and a value. Now if we just want to add data to the list inside of the class called data, the idea on how I want to implement stacks is that I will consider the beginning of the array of the list as the bottom of the stack, and the end of the list will be considered the top of my stack. And because I add to the top and I remove from the top, I will be adding to the end of the list. That's the idea with push, is that I'm considering the beginning of my list to be the bottom of the stack and the end of the list to be considered the top. And because when we add and remove data from a stack from the top, as you would a normal stack, we're going to be adding data to the end of the list. So I will use the append method and I will add the value there. Next comes removing the data. Removes data from the stack. And this will be pop. And we just need itself. And what we'll be calling here is a method from the list class, and that'll be the pop method. And with this, we need to provide the index that we want to pop. So because we're popping from the top and we consider the end of the list the top, we want to remove the last value. Seems simple enough, right? So from here, we're going to have two more functions, one called print stack. This is useless because we already have overloaded the string special method, but I'm just going to put it here for clarity, and I'll provide some space right here. So for here, I'm going to use a simple for loop and say for I, let's keep it simple, in self data underscore. I'm going to print the item and end it with a space. So all print statements here will end with the space instead of the typical new line. After this for loop, I'm just going to put an empty string because this will add a new line. Right, and last but not least, we are going to add a search function for this. We want itself and a value. So here, it'll be quite similar to stack. I will say for printing stack is that for I in self data, I'm going to check if I is equal to value, then we're going to return true. Otherwise, outside of this for loop, we're going to return false. Right, so here we iterate through every element that's inside of the data. Here we check if it's equal to that value. If it is, we return true. We can only get to this statement down here if and only if we iterate through every single element of this for loop and this if statement is not triggered. Right. So here is a simple implementation of a stack. We'll figure this out when we test it with some sort of driver code for the stack. Thank you for watching the video, and in the next video we'll be covering how to make a queue class. Thank you.